Hi, Abdullah. How are you?
Still, he will enter now. 2 minutes.
So basically, we were discussing about limits. So limits, it's the concept we just used to find the approximate value for a function. Okay, what does approximate value means? It means the value of a function. Let's see. Say if we need to find the value of the function fx equals to x square at x equals to 2. And this is fx equal to x square. So basically means the function value when the x approaches to 2 from left hand side and to 2 from right hand side. Okay, so this means the concept of limits for the function of x equal to x square if they would have asked us to find the limits for the function. Okay, let's write it down here. I'll explain mathematically that if the value of x tends towards a and the function value when x tends towards a gives you the value m, then we say that limit for a function when x to tend towards a for this function fx will gives you the value. So this is what basically fx tending towards m means. This is called as limit. This is called as getting the approximate value for the function fx when x tending towards a. Okay, so that's why initially I have mentioned here approximate value and not exact value. So limits, this is the first differentiation. Limits tends to give approximate value. Second point, basically the two conditions which you need to understand. First, I've told you it gives us approximate value by this formula. Second, we need to figure out the value of a function using the concept of limits for indeterminate forms. Okay, so now what are these indeterminate forms? Basically there are 7 indeterminate forms. Okay, you must study before calculating the approximate value for a function by using limits. So they would be like 0 by 0 form, infinity by infinity form. Okay, then it's 0 into infinity form, then it's 1 to the power infinity, then it's 0 to the power 0, then it's infinity to power 0, then it's 0 minus infinity. So these are 7 indeterminate forms which we need to first identify that whether our function basically is coming in either of the form or not. If it is coming in this form, then definitely we'll be able to find the uh, value for a function using the concept of limits. All right. So Abdullah, are we okay? Do you have any doubt till now?
That's understand too.
Okay, perfect. Let's move on further. So I'll be writing here, giving you a demonstration for a function to find the value for this using limits. So let's say that there is a function fx and the graph has been drawn like this here. Okay, they say that the value for this function at x equals to a basically is the value m, which is somewhere lying here. Okay, and they say that the function value basically is L for the remaining values of x for this function fx. But for x equals to a, they say the function value is this solid circle, and here it is a hollow circle. So okay, first I need to discuss these things, that what is solid and hollow circle means. Solid circle means that the value of this function is this value m, and a hollow circle represents that the function value at x equal to a jumps from this value, that is L, to m. All right. Now, okay. Now there would be two things. First, basically, value of a function. There are two terms basically, which I must discuss because that makes students confused. And the second term is limit of a function. So these two are different terms. Okay, these are not alike. What is value of a function? If I'll ask you, Abdullah, the value of the function at x equal to a, tell me what it should be. It should be either L or it should be M. Any idea, Abdullah? Okay, let me tell you. The value of this function at this x equals to a basically would be M. Okay, yes, because this solid circle represents the value of this function itself. And now if we're going to ask you, what is the limiting value of a function at x equal to a? Okay, so these are two different things. So I'll say the limiting value of a function at x tending to, okay, this arrow, what does this arrow represent? This arrow represents that the value of x basically is approaching towards a, either from left hand side or from right hand side, and this is x and this is fx. Okay, so this limit of a function basically here ask you to tell the function value at x tending towards a. So here we'll say that now basically there comes the two concepts of left hand limit and the concept of right hand limit. Okay, so basically what is left hand limit? Again, left hand limit, we say this is the limiting value of a function. What is right hand limit, RHL? It is the again limiting value of a function. What this left hand limit comes from the values of x, which is coming from the left hand side of x equal to. So how are we going to find the left hand limit for the function? Now it's the next question. So I must tell you that to find the left hand limit, you must write down that limit of this function fx and x tends towards a minus. Okay, this is a representation of writing a left hand. When x tends towards a negative, okay, I mean a negative basically represents the values of x which are less than a, these values, any value of x which is less than. So that's why I'm writing a negative. Now also we can write down it like this in this form, that limit h tends towards 0 f a minus h. This is another form. So these two forms you must note, okay, before finding the left hand limit. Now what does it mean? It means that any value of x, okay, when x is approaching towards a, okay, I must tell you when we called x a minus. So a minus means very close value towards x equals to a from left hand side. Okay, so that's why any value of a function when x approaches from left hand side of a and is very close to a gives you the value L. So this is left hand limit. This is how we're going to find out the left hand limit. Okay, after this we're going to find out the right hand limit. Same is the case. We'll write it down. X tends towards a positive fx. A positive means the values of x which are very close to a and is approaching from right hand side towards a. All right, so its limit h tends to 0. The value of the function again will write here as a plus h. Okay, one more thing I must tell you, what is h here? So basically h is a infinitely small positive number. Okay, very small positive number that makes you sound that this a minus h and a plus h basically values are very close to a. So again here, now this value of right hand limit for this function will give you again the same value, that is the L, because this is the value L. Can you imagine when you will come from right hand side towards a, the value of the function which is very close to x equal to a will be the same as the value when x equals to a in a whole circle. Same things happen when you comes from left hand side, the value of the function again will be very close, okay, to fx, which is equals to L. So now the third concept basically which comes, and which is one of the very important concept here, they say that if left hand limit and right hand limit basically, okay, it comes equal, like here L and L both are coming equal, and they also say that if it comes a finite quantity, okay, it should not be any infinite quantity, it should be a finite quantity which we can measure or which you can count. Okay, Then they say that limit exists. Okay, so this is a concept you must remember. Limit exists, plus one more thing, that these two limits must be equal. It should be finite, but also it should be equal to limiting value of this function fx when x tending towards a. Okay.
So give me
So,
like,
sorry, come again.
give me like example.
Okay, yes, I'm coming over the example. Don't worry. Okay, so basically now here we are clear that left hand limit, right hand limit, and the limiting value both are equal and finite. Hence, limit exists. Now let's talk about the example here. Okay, so example in front of you. X square minus 4 upon x minus 2 and limit x tending towards 2. So this is a function. Okay, we need to find that whether limit exists or not, whether left hand limit, right hand limit, and limiting value for functions coming equal or not. Let's talk it about. Okay, so here you can see one more thing from the mathematical approach from this table, that the value of x when it is tending towards 2, you can see that from left hand side I've told you that when x is very close to 2, that is 1.9, 1.99, and like this. So we have taken some examples of x here, and we have figured out the value of fx against these values of x. So I've noticed that fx is coming as approximately equal to 4. Okay, same things happen when we talk about the right hand limit, when the value of x approaches towards the x equals to 2, but from right hand side. So it's 2.1, 0, 1, 0, 0, 1, 0, 0, 0. So we have figured out the value again of x, which is again coming approximately. I've told you now, approximation. Limit is all about approximation. We have to take approximation. So in both the cases, approximate value is coming as 4. That means left hand limit is coming equal to right hand limit. Okay. That means and is finite. That is 4. Finite again is important term you have to understand, remember. Okay, so that's why we say that limit exists, do exist for this function fx. Okay, so we can write down like here left hand limit. So this is called as left hand limit, limit extending towards 2 negative, and the value of fx is coming as 4, as we have also seen from this table. Same things happen, right hand limit, limit fx extending towards 2 positive fx. Okay, from the right hand side you can see. So from both the sides, left hand limit and right hand limit are coming equal, that is 4, hence limit do exist. Let's talk about one more example so that we could have a better idea. Okay, so here it is written that limit do exist, okay, for limit extending to 2. Okay, any question, any doubt, Abdullah, so far? If you have any, let me know.
No, nothing.
Okay, good. So now the second example basically is here on the based on the topics where limit do not exist. So we have talked about one example where limit do exist, where LHL, RHL are equal. Now let's talk about where limit do not exist. So that means in this case, obviously limit, I mean left hand limit should not be equal to right hand limit. In only this particular case, the limit do not exist. Okay. Again, one more important thing. So we have the example limit x tending towards 2, x square minus 5 upon x minus 2. So the same thing you can do again, just building a table and finding the calculations using a calculator. When x is tending towards 2, let's find out the left hand limit very close to 2 as 1.999999. So these are the things you need to do. Okay, and you have figured out that the value of this function basically is getting magnified, getting larger and larger. The next thing when we put the value of x close to 2, you can see 13 jumps to 103, then 1000, then 10,000, and so far when it reaches towards very close to 2, it reaches towards infinity. So the left hand limit basically is coming as infinite for this function. All right. So that's why it is also written here that the left hand limit when x tending towards 2 negative for this function is reaching to positive infinity. Same thing you can see here. When you put the value for x equal to 2 from the left hand side, I mean from the right hand side, so it's 2.1, 0.1, 0.0.1, Okay, so you can see that basically the values is approaching towards minus infinity. So
Okay.
this is the case for right hand limit, and this is the case for left hand limit. We can say that limit do not exist